Hey guys, welcome. This is our last two lessons of the year. So week 16 is where it's landing. We got these last two lessons. We'll review, take the test, finish up our project, any corrections that we need to do, and that'll be it for the year. So you guys have hung in there and done a really good job. So we're looking at lesson 119 and 120 today. So let's flip over to lesson 119. It says finding a hole when a percent is known. All right, well, what does that mean? Let's look. Over 30% of the football fans in the stadium are waving team banners. There are 150 football fans waving banners. How many football fans are in the stadium at all? So we take our 30%, that's what we were given, of means multiplication. The fans, we can call F, T, X, Y, Z, whatever we want to. R, or like is, okay, that's going to be our equal sign. Okay, and then waving banners, 150. So 30% of what number is 150? Okay. First, want to convert this to a decimal. Okay, we move the decimal two places to the left to give us 0.3 times t equals 150. And then inverse of that is to divide. Okay. And then we end up with, or we could draw this out, our total fans parts, 30% or 3/10. Do 10 of these. We do that math and we end up that there's 500 total fans in the stadium. Let's look at example 1. It says 30% of what number is 120? Find the answer by writing and solving an equation, model problem with a sketch. Okay. 30% of what number is 120? So let's simplify this down. First, this is a percent, so we need it to be a decimal, so we move it two places to the left. And we'll just call it 0.3w because that's multiplication. So our coefficient is or equals 120. Then we just divide both sides by 0.3. Any number divided by itself is just 1. Same thing with decimal numbers. And when we divide by a number less than 1, that's going to make it bigger. So when we go 120 divided by 0.3, we get 400. And we could have also done our 30%. We could do 20. And that's why I don't love doing this way, because then you got to draw it out, make sure they're even. It doesn't look that good, but in 30%, so 3 of the tenths were 120. So that means we're dividing 120 into these three groups. There's 40 in each. We fill in 40. For all of them, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of 40. 10 times 40 is 400. So I think this way is easier and quicker, which I like both of those, but we could still do it this way. If you're more of a visual learner and kind of want to see what's going on, you could draw it out and break it into 10 equal groups. 3 of the 10 were 120, so 40 plus 40 plus 40 is 120, and then figure out the total off of that. Not a wrong way to do it, just might take you a little bit more time to do it. Example 2, 16. 16 is 25% of what number? Okay, so first, let's just write it into an expression. 16 is, so 16 equals 25%. We're going to make that 0.25 of what number? Let's call it x in this example. Here we want to get x or n, a, b, c, whatever you're calling it by itself. So we're multiplying, so we need to divide. And that gives us x equals 64. We could have drawn it out like they do here. So 25 is 1/4 is a fraction, so we could do 1/4. If 1/4 is 16, then we're going to do 16 times 4, which gives us 64. Because dividing by 0.25 is the same as multiplying or dividing by 1/4, which is the same as multiplying by 4. So either way we want to go about solving it, we can do it either way. If you have one that you prefer and you feel comfortable with, even if it says draw it out and you solve it the way we did, I'm not going to mark you wrong, obviously, if you got to the correct answer. That practice set we will do together. Okay, let's go ahead and look at volume of a cylinder, our last lesson of the year. I know it's so sad. So a cylinder, again, if you think of, let's say you have a coin and a block of clay or something that you can press down, it's going to be that same circle all the way down until you stop applying pressure. That's essentially what you have with a cylinder. So how we find it, the volume of it is we take the area of the circle and then we multiply it by the height. The distance between this circle and this circle is the height. So even if we have, if I can get this over here, let's say we have, we'll be able to see it. We have our canister right here, whether it's sideways or upright, it's still a cylinder. So the distance between our circle top and our circle bottom, that's going to be the distance here is the height. So even if it's laid kind of on its side like this and it's still a cylinder, the height still refers to the distance from this circle to this circle, our two bases. So don't get confused. If it's standing upright, well, that's the height. If it's laying on its side, essentially, the height is still the same that we're looking for. So sometimes it'll be drawn in a different orientation. So let's take a look at this. So it's a cylinder, so a congruent circle top, and then one on the bottom that we can't really see, but we're given enough information to solve for the volume. And this is also on your reference sheet. I think it may be expressed as base area, which we know the base is a circle. We know how to find the area of a circle, and then we multiply that by the height. Let's go ahead and so what are we given? We're told that this is 10, so this is my height. We're told that the diameter is 20, which means the radius is 10. So that's a 0 right there, 10. Because the diameter is 20, radius is always half the diameter, so it's 10. Okay, so area of a circle. So again, it's going to be base area, capital B on a reference sheet times the height. Okay, well, base area, it's a circle, so I know how to find the area of a circle. So pi r squared times the height. That's how we're going to find the volume of a cylinder. We're told to use, okay, we'll use 3.14. Okay, so 3.14. Radius is 10, not 20, so 10 squared, which is 100, times the height, which is also 10. So this gives me 3.14 times 100, which is 314, times 10, which is 3,140. And then again, what essentially we did is centimeters squared times centimeters. So that's where we get centimeters cubed. So anytime we're working with volume, regardless of the units, it's always units to the power of 3, because we multiplied whatever, in this case, centimeters by centimeters by centimeters. So that's where we get cubic centimeters. So it's three-dimensional. So think units to the power of 3, 3 and 3. It's an easy way to remember it. So our volume comes out to be 3,140 cubic centimeters. It looks like that's it for our examples, and we got one practice set problem. We'll go over that in class, and we'll be cruising right along to almost summer. So good job, you guys. We'll see you in class. We'll finish up any corrections or projects and everything like that, and finish out the year strong.